x plus 7 over x squared plus 5x plus 4 plus 6 over x squared minus 3x minus 4 equals 3 over x squared minus 16. The first thing that I want to do is to first factor all of these denominators. So x plus 7 over, factoring this becomes x plus 4 and x plus 1 plus 6 over, factoring this denominator is x minus 4, x plus 1 equals 3 over, here I have the difference of squares, and so that'll be x plus 4, x minus 4. Now if I take a look at these denominators, I can come up with my common denominator as x plus 4, x plus 1, x minus 4. So what I want to do is to multiply all of these pieces by this common denominator. When I multiply this first one by these three terms, I could see that the x plus 4 and the x plus 1 would drop out. So I would have x plus 7, because it was already there, times x minus 4, plus 6 times, let's take a look, the x minus 4s would drop out, the x plus 1 would drop out, so the piece that I'm missing is x plus 4 equals 3. The x plus 4 and the x minus 4 would drop out, so the piece that I'm missing would be x plus 1. This greatly simplifies what I previously had. Now let's multiply all this out and see where we're left with. X squared plus 3x minus 28 plus, distribute that 6 throughout, 6x plus 24 equals 3x plus 3. Let's go ahead and clean up this left side first. So x squared plus 9x minus 4 would equal 3x plus 3. Then I can subtract 3x from both sides, as well as subtract 3 from both sides. I want to get all my terms on one side. So I have x squared plus 6x minus 7 equals 0. What I've created is a new equation, a new quadratic that I can factor. So x plus 7 times x minus 1. Now that I have it factored, let's set each of these factors equal to 0. So x plus 7 equals 0, or x minus 1 equals 0. Solving this one first, we can subtract 7 from both sides to give me x equal negative 7. Or I could add 1 to both sides to get x equal 1. My solution then is negative 7, 1. Since my original problem had variables in the denominator, I would want to, of course, check these to make sure that I didn't have any numbers that wouldn't work in that denominator. But in this case, both of these numbers work. So my answer is negative 7, 1.